Hello everyone, my name is Ramirez, and in this video we will be using the one sample z-test. We are going to use this z-test to compare a sample statistic to a population parameter. We will then determine if the sample was or was not representative of the population. So in essence, we will examine the difference between a sample and a population. We will only be testing one group, and the appropriate test statistic in this case will be a one sample z-test. The first thing we have to remember is that there are 8 steps that must be used for the computation of the mean. Not the mean, but actually the z-test hypothesis. The first thing we have to do is we have to state the null and the research hypothesis. The null hypothesis states that the sample average is equal to the population average. If the null is not rejected, that means that the sample is representative of the population. If the null is rejected in favor of the research hypothesis, that means that the sample average is different from the population average. We will identify the null hypothesis as H null, right here, H null, and this states that the sample mean is equal to the population mean. Our alternative hypothesis, which is H1, that's going to say that our sample mean is greater or does not equal our population mean. In step number 2, we are going to set the level of risk or the level of significance or type 1 error. In our case, we are going to use 0.5, which we can also state that it's going to be 5%. And we'll go into that a little bit further once we get going with the formulas in the video. Step 3. We're going to choose the appropriate test statistic, and in this case, we are going to be using the z-test. In step 4, we're going to start doing some computation for the test statistic and the values. First, we have to determine what the SEM, or the standard error of the mean, is. And the way we calculate that is by taking our standard deviation, right here, and dividing it by our size of the sample, by the square root of the size of the sample. And we'll get into that a little bit further also when we have our problem that we have to work on. Once we have our standard error of the mean, we can plug that information in to get our z-value. And the way that we get our z-value is by subtracting our x-bar, or the mean of the sample, by the population average, represented here by mu, and we divide the whole thing by our standard error of the mean. In step number 5, we will determine the value needed for the rejection of the null hypothesis. We're going to be using 5%, and we will also be making sure that this is a one-tailed test. We're only going to be looking at the right side of the bell curve. If we were looking at a two-tailed test, that would give us a different critical value. In step number 6, we are going to be comparing the obtained value with the critical value, or actually our z-value with our critical value, and then we'll determine which one is higher, and that should help us either reject the null or accept the null hypothesis. And in steps 7 and 8, we will revisit our null hypothesis and our research hypothesis once more. The sample problem that we're going to be working with today, I retrieved from www.statisticshowto.com, and you could actually access that same problem, and you could go ahead and try to solve it once this video is finished. The sample problem states that a principal at a school claims that his 8th grade students are above average intelligence. A random sample of 30 students have IQ scores with a mean score of 112. Is there evidence to support the principal's claim? The mean population IQ is 100. The standard deviation is 15. And the IQ scores are normally distributed. For our formulas, we will be using the mean score, the mean population IQ, and also the standard deviation. So for step number 1, we're going to address or state the null hypothesis. We're going to identify it by H null, and that only states that our population mean will be equal to our sample mean, or that our research hypothesis, which we will identify as H1, that's going to state that our sample mean does not equal our population mean. Or actually, let's rephrase this information. And we're going to say that the null hypothesis is going to state that my mu is going to be equal to 100, and my research hypothesis that my mu will not be equal to 100. In step 2, we said that we're going to set the level of risk, or the type 1 level of significance, at either 0.05, which will be equal to 5%. And for step 3, we're going to select the appropriate test statistic, which is going to be my one sample z-test. One sample z-test. Here we have our formulas, our standard error mean, and we're going to get that by dividing our standard deviation by the square root of our n, which is the size of our sample. Here we've already plugged in the numbers. We have 15 divided by the square root of 30. So here we will have 15. That's going to be divided by 5.477, and we get 2.738 as our standard error mean. For our z-value formula, we will take x bar, or the mean of the sample, subtracted by the population average, and we're going to divide it by our SEM, or our standard error mean. We've already plugged in the numbers, so let's continue with the formula, working it out. 12 divided by 2.738. So our z-value, it's equals, if we divide 12 by 2.738, we get 4.38 as our z-value. So once we have our z-value, what do? Actually, our next step is to go and look at our bell curve. So let's start working with our bell curve. We know that our z-value is 4.38. Our population value, mean value, is 100. We also know that our type 1 error our level of significance we're going to set at 5%. So by us setting this side at 5%, we know that from here all the way down is going to be 95%. So by doing, and let's look at the rest of our curve, we know that this part right here, that's going to be 50% of the curve. And we know that this part would have been 50%, but up to here, we know that that is 45% of my curve. Next, I'm going to try to figure out what is the z-value for this part of my bell curve. And I know that this is 45%, and it's also on the right side of my bell curve. So I'm going to look at a right-sided z-table. In this right-sided z-table, I'm going to look at 45%. I know that 45% is, in decimal form, 0.45, and we have here 0.4505, that's a little bit over, and we have 0.4495, so I'm going to be somewhere in the middle here at 1.64, but because I'm a little bit towards 5, so I'm going to say I'm going to be at 1.645. So 1.645, that's going to be my z-value for the 45%. Now I know that my limit right here, it's going to be 1.645, and this is going to be my rejection area to reject the null hypothesis. So if my z-value is greater than 1.645, then I can, in essence, reject the null hypothesis. So I know that my z-value is 4.38, and that is greater than 1.645. So I can, in essence, reject the null hypothesis. So if we go back to the problem, we could actually say that we have rejected the null hypothesis and the population does not equal 100, or actually, yeah, it does not equal 100. And thank you so much for your time. Once again, my name is Ramirez, and please keep looking for some more of my videos.